Today we're going to talk about common factoring, which is the backbone of all the factoring you need to know. A factor is a number that divides evenly into another number. And you would have done this in elementary school. What are the factors of 12? So factors of 12 are two numbers that divide into 12. So 1 times 12, I'm going to use a dot for multiplication. 1 times 12 is equal to 12. What else? 2 times what? So we usually go from start at 1. 1 times 12, 2 times, then 3 times, then 4 times, if we can. 2 times 6 is 12. What about 3? 3 times anything? Yep. 3 times 4 is 12. What about 5? 5 times anything? No. 6 times anything? Well, once you get to that halfway number, half of 12 is 6, then, and we already have the 6 there, then you're not going to go any further than that. So we can also list these numbers. We could also list them in order. I'll put that underneath. So in order we have a 1, 2, a 3, a 4, a 6, and a 12. Those are all the factors of 12. Let's do the same thing for 18. What are the factors of 18? Let's start with 1. 1 times 18. 2 times anything? Well, yeah, because 18 is even, so it's going to have to be 2. 2 times 9. How about 3? 3 times 6. How about 4? 4? No. And you can use your calculator. 18 divided by 4, it doesn't work evenly. How about 5? 18 divided by 5, that doesn't work evenly. How about 6? Well, we already had 6 right here. So I don't need to do that one again. And then 7, no. 8, no. And now we're at 9. So we're at our halfway of 18 is 9, and I already have 9 here, so I can stop there. Let me just erase some of these extra markings I made here. All right, those are all the factors of 12 and the factors of 18. Once you have factors of two numbers or terms, so we did 12 and 18, the largest factor they both share is called the greatest common factor. Greatest common factor, or GCF. So the greatest common factor of 12 and 18. What is the greatest common factor of 12 and 18? I'm going to look at all these numbers. I'm looking for the biggest number they all share in common. And that's why it's helpful to have written it in a list like this. It's easiest for me to see the big number here is a 12, but I don't have a 12 with the 18. The biggest number they share is a 6. So the greatest common factor of 12 and 18 is 6. If you're really good with your multiplication tables, you might have been able to figure that out without having to even write out the numbers. And that's the point I hope we all get to, that we can find a greatest common factor quickly without having to do a list of numbers. And if that's the case for you, then you're going to find the rest of this lesson is going to be, the front of the page anyway is going to go by pretty quickly. Okay, part 1. Now let's talk about a greatest common factor. Common means shared by all. For example, you have this course in common with everyone else in this room or in this online version. You all share a place in this course. You have this course in common. Find the greatest common factors of 24 and 36. Same thing that we did above. So first of all, I want to list the factors of 24. So I can list them if I'm pretty good with my multiplication tables. I'm going to list these just in order. I'm going to go through them in order. I don't start with 1. 1 is always a common factor, always. So we don't even consider it because it's just always there. So I'm going to skip 1. I'm going to go to 2. 2 is a factor of 24, as is 3. And what about 4? Yep, 4 is. How about 5? No. So I'm doing the division in my head. I'm doing 24 divided by 5. No. 24 divided by 6? Yes, that works. Can I do 24 divided by 7? No. How about 8? Yes. 24 divided by 9, no. 10, no. 11, no. 12, yes. And now we're halfway. So those are my factors of 24. Let's do the same thing for 36, except I'll write them out in pairs. So starting with 1 in this case, we get 1 times 36. So 1, as I said, I could put 1 here, but 1's always there, so just to save space, I just don't put it. 1 times 36. What about 2 times anything? 2 times 18. How about 3 times something? 3 times 12. What about 4? 4 times 9 is 36. How about 5? No. 6 times 6. 7? No. 8? No. 9? Yes, but I already have a 9. 10. So I have to go all the way to halfway. 10, 11, 12. I already have the 12. 13, 14, and then there's nothing until the 18. So really, once I start duplicating numbers, I know I'm not going to have to go any further. But these are all the numbers I have for 36, but I wrote them as pairs. So what are the common factors? We don't count 1 here. Is 2, so it's a little easier to see when they're in a list like this. That's why hopefully you can see the benefit of writing it this way. Is 2 common to both? I've got 2 here, and yes, I have 2 down here. So 2 is common, so I can put 2 in. What else is common to both? Is 3 common to both? Yep, I've got 3. And while I'm at it, I've got 4. And I'll keep going. I've got 6. And 8 isn't common to both, but 12 is. So let's list all those. 2, 3, 4, 6, and 12. Those are all common factors. Now the most important step is identifying the greatest of all of those common factors. Which one is the largest, and it's always going to be the biggest number. So the greatest common factor of 24 and 36 is 12. 12 divides evenly into 24 and to 36. It is the greatest common factor. Example 2. Now it gets a little harder because I have variables as well. 12x squared and 18x. So let's just remember that numbers go with, that's not a good line, numbers go with numbers and letters go with letters. I'll highlight that. So I'm going to first look at the numbers. The numbers that are factors of 12 and 18. Now I know we already did these, so I'm just going to do them a little more quickly this time. And I'm going to write them in order. I'm not going to count 1. 2 is a factor, so is 3, so is 4, 6, and we always count the big number itself, 12. Those are all the factors of 12. Factors of 18, again we already did these, but 2, 3, so they were up here, right? We already did this up here. But that up here I listed them as pairs. So down here I'm just going to put them in order. 4, no. 5, no. 6, yes. 7, no. 8, no. 9, yes. And then we don't have any other factors of 18 until we get to 18. So the greatest common factor, I'm not going to list, up here I listed all the common factors, right? I'm just going to skip to this part right here. I want the greatest common factor. What's the greatest common factor of these numbers? They both share a 6. So 6 is my greatest common factor of the numbers. Now let's go down and do the variables. So remember the rule is numbers with numbers, letters with letters. So looking at the x's, these are a little more tricky. They're a little harder, they're more abstract. So x, I could write x as x times x, that's x. Or I could just write it as x squared. So the factors are x and x squared. This one is written twice. Just like up here we had 6 written twice, but the factor we just counted it once as a 6. We didn't count it twice. So the factors are x. I may actually write that out here. The factors are actually x and x squared. Those are the factors. The factors of a single x, it's just itself. It's just an x. So the greatest common factor that the letters share is just the single x, because the second one doesn't have an x squared. So the greatest common factor is an x. The greatest common factor of all means I want the greatest common factor for both terms completely. I just take these two and put them together and I write 6x. That's the greatest common factor of those two terms. Next one's a little harder. Find the greatest common factor of 5a, 25a squared, and 10. We've got 3 terms this time. Remember what I have up above here, which is that in blue highlight, numbers with numbers. So I've got to highlight the numbers. I'm going to do the numbers first, find their greatest common factor, and then I'll find the greatest common factor of the letters. So the greatest common factor of the numbers, the factors of 5 are simply 1 and 5. So I'm just going to put a 5 there. That's the only, again, you can put the 1 if you want to, it doesn't matter, it's just not needed. 25. So 25 has factors 5, because 5 times 5 is 25, but I'm only going to write it once. 5 and 25 are the factors of 25. The factors of 10 are 1, 2, 5, and itself, 10. Now over here you'll see it says coefficients and constants. So we've already talked about vocabulary in this course. Coefficients are, like this 5 is a coefficient and the 25 is a coefficient because they are the numbers in front of the letters. 10 is a constant because it has no variable. So it's just called a constant. So that's the difference between the words coefficients and constants. Now let's look at the variables. The variables are an a squared and an a. So an a squared can be broken down to a times a. So a is a factor. And then the term itself, a squared, is always written. For a, the only factor is a single a. Now let's look at the greatest common factors. The greatest common factor here, is there any number other than 1 that repeats? Sometimes there's not, but there is. There's a 5. So 5 is the greatest common factor for the numbers, the coefficients and the constants. What about for the variables? This is a bit of a trick question here. It looks like they both have a common factor of an a, but they don't, because 10 has no variables. And since 10 has no variables, I can't say that a is common because it's not common. Common has to be shared by all, and it's not. So there is no common factor for the variable. So we're just going to leave that blank, or you could put no common factor, no greatest common factor, or you could just put not applicable. Just leave it blank, it's fine. There is no common factor. So the greatest common factor for all of them is just a 5. The greatest common factor of all 3 of these terms, the only thing they have in common, the greatest thing they have in common is a 5. They have no letters in common because of that pesky 10. It has no variables, so it ruined it for the other 2 which do have variables, so we can't have a greatest common factor. Obviously, writing a chart out is tedious and inefficient. Let's see if we can start doing it in our heads. That's the ultimate goal. Example 4. Find the greatest common factor of 15x squared, 20, and negative 30x. And the first thing I see right away, especially after the example that we just did right here with this no variable thing, is the 20 is a constant. It has no variables because it's a constant. That means there is not going to be a common factor for the variables. If the 20 weren't there, this one has a single x, this one has an x squared. If it weren't there, then I would say my common factor is an x. But the 20 is there, so let me just erase this. So let's look at the numbers, the greatest common factor of the numbers. The numbers are 15, 20, and negative 30. Those are our 3 numbers. So depending on how good you are with your multiplication tables, we've got a 15, we've got a 20, and we've got a negative 30. So in your head, can you think of what the greatest common factor is? And that's the goal, is that eventually you can do that. But if not, you're getting out your calculator and you're finding all the pairs of factors. So for 15, you know that's 1 times 15 and 3 times 5. So you can continue to do that for each of these. 1 times 20, 2 times 10, 4 times 5. And for negative 30, or maybe you prefer writing them out as a list, and you could do that. 1, I'm not going to count the 1. We've got a 2, 3, there's a 5, a 6, kind of running out of room here, 10, and a 15. So you can choose to do what I just did here, kind of on scrap paper. It's not something you need to show your work for, because that is math that by the time you're in grade 10, you can either just do it with your calculator or you can do it with your head. You don't have to show me that. For a question like this, you wouldn't have to show that work. If I gave you a question like this one above here, it said, what are the factors of 12? Well, then of course you're going to have to list. It says, what are the factors of 12? Then you would have to list them all out if it specifically asks for that. But here, we just want to go straight to the blank line. So what is the greatest common factor of all the numbers? Take a look at all those numbers there. What's the biggest one that they all share? The 5. 5 is all there. Now you might be thinking, well, no, there's more. There's like, look, there's a 15 here and a 15 here, but there's no 15 that's factor of 20, so we can't use a 15. It has to be common to all of them. So the greatest common factor of all the numbers is a 5, and we don't need to worry about the negative right now. Just make it a positive 5. The greatest common factor of all terms, just a 5. I have no letter here. There should be no X here because there's not an X common to all of them. So the greatest common factor of all of them is just a 5. Now we need to apply what we've learned about factoring to polynomial expressions. Part 2, factoring polynomial expressions. In order to properly factor, you must eventually be able to divide polynomials in your head, as I've said. But to start, we're going to write down all necessary steps. So example 1 says factor 8x squared plus 12x. That's what we have to factor. And over here, we've got step 1. We're going to write down the greatest common factor of all terms. Now, if you need to do that work on scrap paper, then I highly recommend you do that. Let's look at the numbers first. We've got an 8 and a 12. What's the greatest common factor? Well, there are a couple of common factors. 8 and 12, they both have a 2 for a common factor. They both have a 4 for a common factor. Do they have anything else? No, because 4 is half of 8, so I can't go any beyond that. So the greatest common factor of the numbers part is going to be a 4. And what about the variables? I've got an x squared and an x. What's the greatest common factor of those two? It's got to be the smaller one. It's got to be the x. Because this term here does not have an x squared in it, so I can't say x squared is a common factor if it's not even there. Step 2, rewrite the question as division with the greatest common factor in front and as denominator. Here's what I mean by that. So I'm going to rewrite the question. Let me do that first. 8x squared plus 12x, rewrite the question as division with the greatest common factor in front. So what that means, I'm going to put brackets here. I'm going to put kind of a bigger bracket below. You'll see why in a second. And my greatest common factor I'm going to put in the front. That was this number here, the 4x. That's our greatest common factor. So 4x goes in the front. And then I divide each piece by that 4x. So that is your step 2. It's actually the first thing you're going to write down for me, because step 1 you do in your head. Hopefully you can start to do this in your head soon. You get this number and then you show this work here. So that's the next step. Now what do we do with that? Step 3, we simplify the expression. We leave the greatest common factor in front. This is the greatest common factor. We're going to leave it in the front, but it should be gone as a denominator. So the 4x is going to stay here. Now I'm going to actually divide. What is 8x squared divided by 4x? It should work evenly if we found the correct greatest common factor. 8 divided by 4 is 2. X squared divided by x, we subtract the exponents. X squared divided by x is just x. Then we have this plus sign. And now we do the second term. So 12 divided by 4 is 3. And then x divided by x, they're exactly the same. They cancel out. So we don't write anything there. We just close the bracket. They cancel out to a 1. So that is factored. 4x times 2x plus 3 is factored. And if we went back to our previous lesson and you started with that, if that was your question and I said expand, you would multiply that together there, 4x times 2x, and you would get 8x squared. And you'd multiply. This is what you would do if we were doing yesterday's lesson. Plus 12x. You should get the same answer back. That's how you know you factored it correctly. That's how you can check. You can multiply it out, but we don't need to do that. Okay, example 2. All right, example 2, factor 4y minus 24y squared. So we're going to follow our steps. Step 1 is write down the greatest common factor of all terms. What is the greatest common factor? Let's look at the numbers first. So greatest common factor. We've got a 4 and a 24. Don't worry about the minus sign. We've got a 4 and a 24. Greatest common factor there is going to be a 4. So the number can never be bigger than either one of your numbers. So this number is a 4 and this is a 24. So the smallest number is as high as you can go with the greatest common factor. I could never say my greatest common factor is a 12 because it's bigger than 4. So my greatest common factor here is a 4. And how about the variables? In the first term, I've got a y. In the second term, I have a y squared, so that I have to go again with the smallest one, which is a y. The greatest common factor is a 4y. Now look at our step 2. Rewrite the equation as division. So this is kind of the weird one where we set it up. So first thing, I'm going to rewrite the equation, 4y minus 24y squared. And then I'm going to make a bigger bracket. My greatest common factor goes in front, an equal sign first. 4y, that's my greatest common factor, and then it goes underneath everything. That's my step 2. And step 3 is to simplify, is to just tidy up those brackets. So my 4y must stay at the front. Now I divide. What is 4y divided by 4y? They're exactly the same, so they're equal to 1, not 0. 1. 24y squared divided by 4y. 24 divided by 4 is 6, and then y squared divided by y is y. That is factored. Okay, let's try it again. Example 3. Factor 4 plus 6a plus 8a squared. First step, what's the greatest common factor? The greatest common factor. So looking at, I'm going to start it right here and put my equal sign here. Look at the numbers. I've got a 4, a 6, and an 8. The greatest common factor there is just a 2. Now let's look at the letters. I've got a constant. I've got an a and an a squared, but as soon as I have a constant, I know that I'm going to have no variables for my greatest common factor, because there's no variable in the 4, so I can't take a variable out of it. So my greatest common factor is just a 2. So I open a bracket, I rewrite the question, 4 plus 6a plus 8a squared, and under each one I put my greatest common factor. My greatest common factor is the denominator. That's what it says here, as a denominator. Now I do the division. 2 stays there, very important. If you don't write the 2, then you're showing me that you didn't know there was a common factor. And that piece right there, that 2 is the common factor. It has to be there. Okay, 4 divided by 2 is 2. 6 divided by 2 is 3, and that had an a. And 8 divided by 2 is 4, and it had an a squared. So there you go. Next one. This one we're going to practice our greatest common factor being a negative. So the first step is to find the greatest common factor of all terms. So we're going to take out a negative this time. So what is the greatest common factor here? So I'm going to put a negative down. I'm going to take out a negative. But what does a 3, a 9, and a 15, what do they all have in common? They all have a common factor of 3 in common. So now there's my greatest common factor in the front. Now I'm going to write out the question. Minus 15, like that. A big bracket. And underneath each one, each piece gets my greatest common factor. And this time we're practicing with a negative. Okay, so there's my beautiful greatest common factor, which stays in the front. Never ignore it, keep it there. Open the bracket. Now what's negative 3 divided by negative 3? Well, they're exactly the same, so they make a 1. And then the x squared is left sitting there, so you need the x squared. Now we've got a negative 3 and a negative 9. So those two together make a positive. Negative and a negative make a positive. 9 over 3 is 3, and it has an x. And how about negative 15 or a negative 3? Now, you can think of that negative as being subtract 15 if you want to, but still we have to put it together with this negative. Two negatives make a positive. 15 over 3 is 5. That's that one done. We're getting faster here. Example 5 says factor and check by expanding. That means it's going to look like what I kind of did up here in red before. Oh, something got erased there. Factor and check by expanding. So first, go back to your steps. Step 1, find the greatest common factor. We've got an 18 and a 9. What's the greatest common factor of those numbers? It's going to be a 9, so I'm going to put that there. Now we look at the letters. We've got an x squared and an x. What's the greatest common factor? It is an x. So 9x is my greatest common factor. I rewrite the question, but underneath the question, I have to put my greatest common factor as a denominator. Now, I'm going to open a bracket here and divide. First, 18 divided by 9 is 2. X squared divided by x leaves me with a single x. And here's where students, even in grade 12, they make this mistake. They just say, oh, 9x divided by 9x, that's gone, so I'm just going to close a bracket. That's wrong. 9 divided by 9 is not 0. 9 divided by 9 is 1. So, plus 1. No, we're not done the question because it said factor and check. So I'm going to check this here. I'm going to distribute 9x times 2x. So this is my check line. My check line gives me 9x times 2x is 18, and x times x is x squared. Then I'm going to distribute the 9 to the 1. 9 times 1, 9x times 1 is 9x. Is that the same as the question? Yes. So that check shows me that my factoring is correct. Example 6. A rectangle has an area of 14x squared minus 21 centimeters squared. Find the dimensions of each side. What does that mean? It's got an area, it's a rectangle. I'm just going to draw a little sketch here. It's a rectangle and it's got an area of 14x squared minus 21. And that's in centimeters. I got to find the dimensions of each side. Now you know that area of a rectangle, the formula for area is length times width. So I need to figure out the length and I need to figure out the width, and they have to be multiplied together, which means I'm going to factor this. Factoring first, what's our greatest common factor? We've got a 14 and a 21. Greatest common factor of 14 and 21. So you might need a second to think about this, or get out your calculator, find the number that is highest that they both share in common. It's a 7. Now we have, I'm going to erase those circles there because I wrote over, I think it was a plus sign. Yes, the minus, okay. So this first term has an x squared, but the 21 does not have a variable. This centimeter squared is just the units. It's not a variable. So it's a constant, meaning I will not have a variable. So just a 7. I rewrite the question. 14x squared over the denominator. That gives me 14 divided by 7 is 2, and there was also an x squared there. And 21 divided by 7 is 3. So I have written now the question, which was a binomial, into a monomial times a binomial. So I can say that is a length and a width statement. It doesn't matter which one I say is length and width, but I could say my length, let's say the length is 7 centimeters, and the width is the other factor. Width is 2x squared minus 3 centimeters. So just to illustrate that on my little diagram here, I'm going to erase, no, I don't need to erase it. I think I can fit it in there. my length is 2x minus 3, and my width, other way, sorry. My length is 7, and my width is 2x minus 3. So if I multiply these two together, 7 times 2x minus 3, because area is length times width, I will have this for the area, this expression for the area. So there's some complicated pieces in there. As always, let me know if I've made a mistake and I will fix it, and because it does happen. But you have questions to practice with. I suggest watching some of the examples along with you as you do them yourself. Have the video going along so you can hear the instruction as you do the question. Let me know if you need help.